This is Dr. Kavita Singh, Associate Professor in the Department of Civil Engineering, Institute of Aeronautical Engineering. So today we are going to discuss a topic called as physical properties of hornblende, muscovite and biotite. So in the previous lectures we have discussed about the various minerals and their physical properties like olivine, jasper, flint, augite. So today we are going to discuss some more minerals kind of biotite, muscovite or hornblende. So they are also of different kind of groups and they are useful in the industries, they are useful in the various applications as well as in the construction industry. So how they are applicable in the day-to-day life as well as in the application in the various industries we'll be learning today. So let us start this lecture with the first one that is hornblende. Okay, so hornblende is a kind of mineral which comes in the amphobyl group. So it's a amphobyl group where this kind of mineral occurs, and hornblende is a part of amphobyl group and found in many of the metamorphic and igneous rocks. So it is basically this mineral we just found in the metamorphic rocks and igneous rocks. So I think you remember in the previous lecture we have already discussed about what is a metamorphic rock, what is a igneous rocks and what is a sedimentary rock. So metamorphic rock, it is the formation of the rock from the parent rock like a sedimentary or igneous or metamorphic itself when it goes through a very much heat and pressure conditions. So that conditions, it finally the output of that rock is a metamorphic. So this hornblende is a kind of a mineral which is present in the metamorphic rock or even in the igneous rocks. So igneous rocks are also formed due to the help of lava or magma. So these kind of minerals we find in this kind of rocks. Now if we talk about the physical properties, what are the physical properties of these minerals? If we talk about color. So what is the color of this mineral here is, it will be in dark green, dark brown or black color. So basically this hornblende, this mineral comes in the color 2 to 3 colors, that is dark green color, dark brown color or black color. Now if you talk about the streak, what is a streak here? Streak is basically the powder form of a mineral. So once you make the mineral in a powder form, so the color of the powder is called as a streak. So basically when you see the mineral by look, it is not the same color, it is not visible in the powder form. So if the color of the mineral is yellow, then streak may be white in color and streak may be black in color, any other color it can happen. So streak is basically pale grey, greenish grey and colorless. So now here the color of the mineral is green, dark brown and black, but basically the streak of this mineral you have in the pale grey color, greenish grey color or something like colorless. Luster is lustrous to dull. So this kind of mineral, it's not too shiny, it is having a dull kind of luster, and transparency, if you see, opaque to translucent. The transparency of this mineral is having opaque to translucent in a thin particles. Crystal system, if you see, so monoclinic. So this is having a monoclinic crystal system. Crystal habit means elongated prismatic bladed crystals, often granular or fibrous. So it has a bladed crystals, it is in a granular form or a fibrous form, and cleavage is 2 direction about 56 to 124 degrees, characteristics of amphibians. Now fracture is uneven to spray entry. Now hardness, if you see the hardness here, so hardness is 5 to 6 on the Moho scale. So Moho scale, I need not say you again and again. Moho scale is the scale where we measure the hardness of a mineral or a rock. So 5 to 6 means it's a harder mineral. So it's a harder mineral. And next, if we see hornblende, so it looks like this. You can see here greenish, blackish, brownish kind of look you can see here everywhere. And these are the different types. So the color appearance basically when it is found in the metamorphic rock or say igneous rocks, so the appearance of the color may vary due to the presence of different more kind of minerals, because a single rock contains many type of minerals. It contains 2 or 3 or 4 types, many types of mineral it contains. So based on that, the color appearance may change. Now, if you see applications of Hornblende, so it has a application in the various fields. So Hornblende is a complex amphibole mineral with a general formula of CaMe2 3MgFeAi and SiAi or 8O22OH2. So it is commonly found in the igneous and metamorphic rocks and has a several practical application in geology industry and construction industry. Now, if you talk about the applications here, geological and petrological applications. So, in this, you have rock classification under geological and petrological applications. You have rock classification, essential for identifying, classifying igneous rocks like diorite, andesite, and granite. Now, common in amphibolite and hornblende schist, helping in the metamorphic rock classification. And as a geological indicator, it helps in geologists to determine the temperature, pressure conditions under which a rock is formed. Now, if you talk about the industrial and the construction applications, so in this we have crust stones and aggregates. Like hornblende is rich in rocks are used in the crust stone in the roads, railways, and the concrete production. So basically, it is useful in the construction field where it is useful in the roads, railway, and the other construction field as a concrete production. Now, if you talk about the dimension stones, some hornblende bearing rocks, like example as a granite, are used as a decorative stone. It is used as a decorative stone for the countertops, monuments, and the buildings. So it is even used for the decoration purpose, if you're using the building and even in the countertops as a monuments, as a buildings in the construction field. Now, if you talk about the scientific and research applications, so it is useful as well in the scientific and the research applications, where you have petrology and thin section analysis. In this thin section analysis, it helps the scientists to study igneous metamorphic processes and radiometric dating. Some varieties of hornblende contain potassium can be used in KAR dating and determine the rock ages. Now, environmental and chemical applications. So, environmental and chemical applications, if we see soil formation, weathering of hornblende contributes to the soil fertility. So, hornblende is a rock or a mineral, we can say. So, when the weathering will take place and that the weathering material, when it mixes into the soil, that makes the soil as a fertile soil, fertility by releasing calcium, magnesium, and iron. Now, water filtration. Some hornblende minerals help in the natural filtration of the groundwater. It is also used in the natural filtration of the groundwater filtration. Now, coming to the mica group or muscovite. So, muscovite, it is a mineral which comes under the mica group. So, mica group, we have two types of mineral. One is muscovite, other one is biotite. So, muscovite is a mineral. It is having a shine. It is having a luster, which has a huge applications in the various industries because it has a heat resistant kind of property. And muscovite, common member of mica group, found in the granitic rocks and the metamorphic rocks. So granitic rocks means granite rocks like which is formed by the lava or magma, or metamorphic rocks which are formed by the metamorphism, and where this kind of shine, if you see in this kind of rocks, if you see a shiny kind of material in this kind of rocks, that means it contains mica present in that. Now, what are the physical properties of muscovite here? Is color, colorless, pale green, grey, silver, or light brown. So it comes in the pale green color, it comes in the silver color or a light brown color. Luster, if you see, vitreous to pearly, it has a luster of vitreous or a pearly kind of luster. And streak is white. Always the streak will be white. When it is in the powder form, it comes in the white color. So what is the hardness here? If we see, the hardness is 2 to 2.5. So 2 to 2.5 is it's a soft kind of mineral, soft mineral. So this is a soft mineral. So on the Moho scale, when it is measured as 2 to 2.5, that means this hardness is having a very less hardness. So this is the softest mineral. If we talk about muscovite, it's the softest mineral on the Moho scale. It easily breaks into slides. It easily breaks into thin sheets. So cleavage, if you see, perfect basal cleavage into thin or flexible sheets. Fractures, if it has a unique uneven and splintery kind of fracture. Specific gravity is 2.763. There's a 2.763 is the specific gravity. Transparency is transparent to translucent. So it is transparent to translucent. And the crystal system is monoclinic. The crystal system is monoclinic here. Now, crystal habit is the thin tabular crystal, scaly, aggregates, foliated or platy. So, always this kind of mineral, when you try to break it off, it breaks in a thin sheets, thin sheets, and it has a perfect cleavage for the from the one side. And tenacity, if you see, elastic thin sheets are flexible, retain to the space after bending. Now, these are the different types of muscovite. We can say it has a different colors here. So all are having a thin sheets here. So this one is a different one, but because of the content, the formation, this may appear in a different color. Now, what are the applications of muscovite? So applications of muscovite has a huge applications in the industrial field. So muscovite is a physiosilicate mineral from the mica group, has a wide range of applications due to its transparency, its flexibility, and basically it's a heat resistant. So most important part here is it's a heat resistant. Okay, heat resistance and electrical insulation properties. It has electrical insulation property. So this is also a very important part here, heat resistant and electrical insulation property. Now, in the industrial applications, if you see, it has electrical insulation used in the capacitors, transformers, insulating tapes due to its high dielectric strength and heat resistant. Paint and coatings added to the paints, coatings, sealants for the durability, and it has a UV resistance and the weather protection. Plastic and rubber used as a filler to improve the flexibility. It is used as a filler to improve the flexibility and the mechanical strength of the rubber or plastic. Now, if we talk about the geological and petrological applications, we have rock classification, metamorphic indicator. So, found in granite. It is found in the granite, pegmatite, schist, and genesis. So, these kind of geological applications we have, like rock classification, basically it is found in the granite, pegmatite, schist, and genesis, helping the geologist to classify the rock. As a metamorphic indicator, its presence in schist and phyllite indicates the medium-grade metamorphism. Construction and building materials, roofing and the fireproofing. Used in the roof shingles, fire-resistant boards, cement and concrete additive, enhances the durability, reduces the cracking in the cement-based materials. So, in the construction field, it is also used in the roofing and as a fireproofing because it's a heat-resistant and has a electrical resistant, so it is used as a fireproofing or roofing here. Cement and it is used as an additive also, and hence the durability and reducing the cracking in the cement-based materials. Now, cosmetics and personal cares. If you talk about cosmetics, so muscovite is a kind of mineral which is hugely or widely used in the cosmetics field and personal care, like in makeup industry, used in the foundations, nail polish for the shimmering effects, or skincare products found in the some lotions, creams for the radiant glow. Environmental and agricultural applications, it has a soil fertility, slowly it releases the potassium, benefiting the plant growth, and it is also used in the water filtration. It is used in the water filtration for impurities in the water treatment process. Now, scientific and research applications. So, it has a thin section studies. Scientific and research application, it has a thin section studies. Used in petrology, mineralogy to study the rock textures under the microscope. Radiometric dating, so contains potassium, making it useful in KAR dating for determining the rock ages. Now, coming to the third mineral, that is the biotite. So, biotite is a mineral, it's a commonly like a similar to the muscovite. So, biotite also is a mica group, it comes as a mica group. So, these two are the minerals which comes in a mica group, muscovite and biotite. So these both are coming in the mineral as a mica group. So both are having the similarity here. So biotite is another mica mineral typically found in the igneous and metamorphic rocks. So this is basically found in the igneous rocks or the metamorphic rocks like a granite and schist. Now, what are the physical properties of biotite here? Color. Color is dark brown, black or greenish black. So it comes in a dark brown color, it comes in a black color, it comes in a greenish black color. It has a luster with just pearly, it has a streak of white to grayish. So when you streak this mineral, we get the color as the white to grayish in color. And hardness is 2.5 to 3. So hardness is almost same of the muscovite and biotite. 2.5 to 3. That means it's a soft kind of mineral. It breaks very easily. Cleavage has a perfect basal cleavage sheets, easily split along the planes. So you want to split the along through the planes, it will split along the planes. And fracture is uneven to splintery. It is a uneven fracture it has to the splintery fracture. Specific gravity is 2.7 to 3.4. And if you talk about the transparency, it has a opaque to translucent in the thin flakes. Crystal system is monoclinic. Crystal habitat is tabular to platycrystal, scaly, aggregate and foliated masses. Now, tenacity is flexible but inelastic, bends and doesn't return to the original state. Now, these are all the biotite here. Types of different biotite comes in a different color. Here you can see you have a silver, you have a brown color, you have a gray color or black color. In different colors we get this kind of mineral here. Now, applications of biotite. So, when you talk about the applications here, so it has a geological and petrological application. It has a application in the rock classification. So, biotite is a key mineral. It's a key mineral for in a granite or gabbro, diorite or pegmatite, and which helps the geologists to classify the igneous rocks, and commonly in genesis and schist, making it useful in identifying the metamorphic rocks. So as a metamorphic indicator also it is used as a metamorphic indicator. The presence of biotite in metamorphic rock indicates a medium to high grade of metamorphism. Now, industrial and construction applications. So if you talk about industrial and construction applications, so crushed rocks and aggregates. So it is used as a crushed rocks, crushed rocks and aggregates. So found in rocks used for road constructions. So some rocks is a metamorphic rocks or igneous rocks. Those rocks which are used in the construction. So in those rocks, this biotite is found. And the concrete and the railway ballast, insulation material. It is also used as a insulation material. So due to its heat resistance, sometimes it is used as a fireproof material too. So it is a heat resistant and fireproof. So that's why it is mostly used in electronics or as a roofing material, as a fireproof material to try to avoid the disasters. Now, environmental and agricultural applications. So this has a environmental applications and agricultural applications too, like soil formation. So biotite weathers into clay minerals. So when biotite starts weathering, so weathering, I hope you remember what is weathering. Weathering is the breakage of the mineral or rock due to the climatic conditions into fine pieces, that we call it as weathering. So due to the biotite weathers into clay minerals, enriching with the soil. So it mixes into the soil with the potassium, magnesium and iron. So it just mixes into the soil and makes the soil very much fertile. So biotite is helpful in the soil formation, soil fertility formations. So when the weathered biotite, when it is mixed into the soil gets more fertile. Now, water filtration, if you talk about water filtration, so it helps in natural filtration, removal of heavy materials. It also helps in removal of the heavy materials in the soils and the groundwater. Now, scientific research applications, so thin section studies. So, used in the petrology, analyze rock formation, metamorphic conditions, and as a magnetic property, it is also used as a magnetic property. So, due to iron content, biotite can be used as studies in the magnetism in the rocks and aesthetic and decorative applications. So, as a gem and the collector's mineral, while not commonly used as a gemstone, biotite specimens are collected for their unique and crystal structures. And polished slabs in the interiors, it is used, sometimes used as a decorative stones, applications in tiles and the countertops. So these are all the applications on biotite, muscovite and hornblende. So we have studied these three minerals today. These are having a huge applications in the various industries, in the various fields. So it is also important in the construction fields where these all minerals are applicable, because the stones which are used in the construction field that contains this kind of mineral like hornblende or biotite or muscovite. So it has applications in the various fields, like it has in construction, it has in environmental, it has in the soil fertility, it has in a water filtration process, in the soil formation and all. So these are the few of the references which you can go through to find out the more information or more content. If you want to know about this types of mineral, you can just go through this all reference books to find out the more content about it. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.